Now we talk about postulates of Rutherford model of atom. As I already explained you about these three postulates, that atom consists of a small and massive center core in which the entire positive charge, almost whole mass of the atom, is concentrated. This core is called nucleus. Size of the nucleus is very small as compared to size of atom. Nucleus is surrounded by suitable number of electrons so that their total negative charge is equal to total positive charge on the nucleus, and atom is wholly neutral. Electrons revolving around the nucleus in the various orbits just as the planets revolve around the sun. Centripetal force required for the revolution is provided by the electrostatic attraction between the electrons and nucleus. So from here we have concluded that electrons are revolving in the circular orbits around the nucleus. So they can revolve in any of the orbit. According to the electromagnetic theory, this thing I will explain you in chapter EM waves. We people haven't done this chapter yet, but when the classes will be open I will explain you. So according to that chapter theory, according to the electromagnetic theory, it is observed that any accelerated charge is continuously losing energy. Means an accelerated charge particle must radiate some energy. So when electron is revolving in the circular orbit around the nucleus, it is an accelerated motion. So when it will complete one orbit, it will lose energy. After losing energy, it will come to the lower level. Then again it is accelerating, it will lose energy, come to the lower level. Again losing energy, come to the lower level, and finally it will fall in the nucleus and it will collapse it. It means the stability of atom is not explained by this type of theory, by this type of proposed postulates. Then the second thing which this Rutherford can't explain is, in Rutherford an electron can revolve in the orbit of all the possible radii. Electrons can revolve in any of the orbit, as I explained in the earlier point. So it should emit continuous spectrum. But when you will see hydrogen atom spectrum, it is discrete line spectrum. So Rutherford can't explain the discrete line spectrum of the hydrogen by his this theory. So these were the few limitations because of which next model was given, which is called Bohr's atomic model, and this was accepted also. What were the postulates? An atom consists of small massive central core called nucleus around which planetary electrons revolve. The centripetal force is provided by attraction between electron and nucleus. This is same as we did earlier. Of all the possible, now this is very important, all the possible orbits are not allowed for electron to move. Of all the possible circular orbits allowed by the classical theory, electrons are permitted. Only those are allowed. Permitted means the electrons are allowed to circulate only in those orbits which have angular momentum integral multiple of h by 2 pi. This is very important. This is also called the Bohr quantum condition or Bohr quantization condition, that angular momentum of those orbits whose angular momentum is nh by 2 pi, only those orbits are allowed for the electrons to move. They can't move in any of the orbits. While revolving in the permissible orbits, an electron does not radiate energy. This is opposite to this point. Like, it is not possible for them to radiate energy when they are circulating. Here we told that they can continuously radiate the energy and come to the lower energy level. They said when the electron is revolving in that particular orbit where this thing is possible, where this condition hold, in those orbits electron can't radiate energy. These non-radiating orbits are called stationary orbits. So electrons are allowed to revolve around the nucleus only in these stationary orbits. An atom can emit or absorb the radiation in the form of discrete energy photon only when electron jump from higher to lower orbit or from lower to higher orbit. So whenever electron go from higher to lower orbit, it will release the photon, and when it is going from lower to higher orbit, it will absorb the energy of the photon. So according to that, E2 minus E1 is equal to h nu. Next is the derivation of the formula or explanation of the line spectra of the hydrogen atom, you can say. And this is again very important from the board point of view. This year question paper also consists the question about the derivation of this up to here, right? I'll share with you that question also from the board question paper later on after the explanation of this chapter or this topic, you can say, this derivation. So this derivation is very important. So for that, what we have considered, we have taken hydrogen atom, which consists of a nucleus with the positive charge Zd, single electron of the charge minus e, which is revolving around it in a circular orbit of the radius r. Here is the diagram. So there will be the force of attraction between them. So this is the formula that we have already done, so it will be clear to you people. When they are revolving, what will be happening? The centripetal force on the electron must be equal to the electrostatic attraction, that we already discussed earlier, that for the motion centripetal force is provided by attractive forces. So centripetal force mv square r is equal to this force of attraction. From here you have calculated the value of r. Then we apply Bohr condition. From here we have calculated the value of r. From 2 and 3, we'll equate these two values and get the value of velocity. Now put this value of velocity here and get the value of the radius r. See, I've done it here. So from here what we have concluded that r is proportional to n square. What is n? N is called principal quantum number. You people already did this thing in the chemistry, so it will be easy for you to understand. It's proportional to n square. What is Bohr radius? It is a radius of the innermost orbit of the hydrogen atom. Innermost means n is equal to 1. For hydrogen, we will take atomic number to be 1. Put these two values and calculate the value of Bohr radius. This value is 0.53 angstrom. Now we again come to the previous formula of velocity. In that formula, I just separated out this c by n because this is the constant value, right? So I have just separated c by n. When you will do like this, then this factor is come out to be alpha, which is a constant, which is called structure constant. So this we have make another one formula, very simplified formula for velocity for solving the numerical, where velocity is inversely proportional to this n. For n is equal to 1, the value will come out to be this. So you can read out this. It's very easy. This formula you can use in your numericals. Next we talk about the energies. These three formulas are very important for solving the numericals. Energy of the electrons. First of all, we talk about the kinetic energy. Half mv square is equal to this thing. Potential energy k q1 q2 upon r square. We put the values and we get this. Total energy will come out to be like this. When you put the value of the k here and r here, then energy will come out to be like this. R value also you can put it here, right? So the negative sign is there in energy. What does this indicate? It's a very important question. What is the importance of this negative sign in the total energy of the hydrogen atom? Negative sign indicate that electron is bound to the nucleus by attractive forces. Some amount of work is required to be done to put it away from the nucleus. So energy is come out to be when you will put the value of all the constant things, so leaving n square as such. And when you will solve, you will get the simplified formula. Everywhere we'll use this formula only, minus 13.6 z square upon n square. Z square means for hydrogen-like atoms. If you will put z is equal to 1, that is exactly for hydrogen. So for hydrogen, if n is equal to 1, energy is minus 13.6 electron volt. This energy is for the lowest energy. This is for the ground state energy, you can call it to be. For the ground level, that is n is equal to 1, it is called ground state energy, right? And this is the lowest value also, minus 13.6 electron volt. For n is equal to 2, energy will come out to be this. This is called first excited state. For first excited state, n is equal to 2. For second excited state, n is equal to 3. And if we put the values like this, and when you put n is equal to infinity, energy will come out to be 0. It shows that the electron continuously, it shows that the electron can have only certain definite value of the energy while revolving in the different orbits. This is called energy quantization. So from here you can see that they don't have continuous spectra, they have discrete value of energy. One specific value of energy they have, minus 13.6, minus 3.4, and so on. So the energy is also quantized. They have discrete value of energies. As n goes on increasing, energy of states become less and less negative, and approach closer and closer to the maximum value, that is 0, for n is equal to infinity. So electron is no longer bound to the nucleus, that is it become free. So highest energy state is E is equal to minus 13.6 upon infinity is equal to 0 electron volt. This is the energy of the atom when electron is removed from the nucleus and electron is at rest. So we will go back again to our previous relation, like here. Here, when you will put n is equal to 1, then what we will get? After putting the value of this k also, 1 by 4 pi epsilon naught, you will get the value of energy to be like this. For n is equal to 2, energy is this, this and this. So here you can say that how energy is going from this value till 0. So energy of electron is minimum, that is maximum negative in its first orbit, or you can say in its first orbit, and 0 energy, that is maximum in the infinity level. This minimum and maximum energy first orbit means ground state, and 0 energy maximum means infinite level. N is equal to 1 is the ground state, n is equal to 2, 3 are called as the excited states. So this diagram they have drawn. For seeing this diagram, first of all we need to see the page which is adjacent to it. So please see this page. This is the spectral series in the hydrogen atom. As we know, whenever an electron jump from some higher energy level to the lower energy level, a photon of energy h nu will be emitted. This is called Bohr third postulate. Right? We have covered it in the postulates also. So when you will put the value of E2 and E1, this will be the value for E2 and E1. And when you will get it common and put the value of this whole, nu is C by lambda, then h move to this side, C also to this side. 1 by lambda is another a new factor called wave number. And this whole value is called a Rydberg constant. Its value is also specific. This value is also given here. So we have made a simplified formula here, which is called nu bar is equal to r z square 1 by n1 square minus 1 by n2 square. For hydrogen, z is equal to 1, so we left only with this formula. This formula is very important. So when electron jump from higher to lower energy level, their energy levels will come out to be discrete energy levels, and in case we obtain the series which are called as these type of series. This will be clear from the diagram also. Let me explain here, then I'll match these things with the diagram. In this, the spectral line corresponds to the transition of electron from higher to the lower energy level. NF is equal to 1. Otherwise also you people did all this in chemistry, I think so. So it will be easy for you to understand. So 1 by lambda is equal to RH. Put the value of the NF is equal to 1. And Ni is equal to 2, 3, 4 and 5. It means when the electron jump from any of the higher energy level to the level n is equal to 1, then you can obtain this type of things. And when it will jump, it will emit a photon which will lie in which region? UV region. Then Balmer series for NF is equal to 2, and initial levels can be 3, 4, 5 and anything. And for this also it is 3, 4, 5 and 6. So here you can see that we obtain this type of the spectral series. 5 series are there: Lymer, Balmer, Paschen, Brackett and Fund series are there. So there we have drawn the series also. From here it is clear to you. N is equal to 1, N is equal to, N is equal to 3, N is equal to 4. As we goes on up and up, the difference in the energy levels go on decreasing. This you can see from here also, that the difference in the values, minus 13.6, minus 3.4, minus 1.51, minus 0.85, difference between different energy levels goes on decreasing. So energy levels are coming closer and closer as we move toward N is equal to infinity, right? So this side I have written the energy. So here we have N, that is principal quantum number. So when an electron make a transition from higher energy levels to the energy level which is ground level, then we obtain Lymer series, and photon is emitted in a UV region. Second is for Balmer series, and if it will come to the energy level 3, it is Paschen series. Come to the energy level 4, it is Brackett series, and otherwise it is Fund series. So this is the diagram of the spectral series of the hydrogen atom. That's all for this topic. Thank you.